Hello everyone. In this particular video we'll be looking into task number 12 for Advent of Cyber 2024. Name of this task is if I can't find a nice malware to use, I'm not going. Um, this task is related to how a Windows malware works and how you can detect the malware using Windows system events. Uh, which are enabled using SYSMON, and um, we will also see how to configure YARA rules for detecting some specific uh, things in the events. Okay, so let's go through this challenge. Mere malware was scheming quite full of delight to ruin Sokmas and frighten Sokmas, but Glitch and Mixkedi has spoiled his plan by uncovering secrets that expose the man. So nice little poem there. Mere Malware slammed his hand on the table, his eyes narrowing as the report flashed on his screen. Glitch and McSkiddy has uncovered his trail. He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me, but have not stopped me. His confidence stemmed from the malware he had crafted, so devious and advanced that it would easily evade detection. But before unleashing it to wreak havoc on SOC teams and ruin SOCMUS, there was a final step he needed to test it in a sandbox. So, Mere Malware has created some malware. Before using that malware in a attack, he wants to test it out in a sandbox environment. So, sandbox is just a isolated environment where you can test your things. Learning objectives are analyze malware behavior using sandbox tools, explore how to use YARA rules to detect malicious patterns, learn about various malware evasion techniques, implement an evasion technique to bypass YARA rule detection. Okay, um, so first you need to start the lab. For starting the lab, you click on Start Machine. I have already done that. After starting the machine, you will be getting credentials to log in. Um, so the user is administrator, password is this, IP address, your IP address will be different. Um, so yeah, let's see. He slipped his malware into a sandbox to see what tricks it could play and what flaws there might be. For sandboxes you see are used by the wise. Defenders inspect but attackers revise. Again a short poem. Um, I am damn sure they have used ChatGPT to create these poems. Detecting sandboxes. A sandbox is an isolated environment where malicious code is executed. Okay, you already know that. Mere malware knows that before his malware executes, it needs to check if it is running on a sandbox environment. Okay, so he has already written a code within the malware, which is checking whether the malware is currently running in a sandbox or not. So if the malware is running in the sandbox, then it should not continue with its malicious activity. Um, so there is a one technique which the malware uses to check whether the malware is running in a sandbox environment or not. If the directory C program files is present uh, by querying a registry path, this particular registry path, this is basically Windows registry path if you guys don't know. Uh, Windows registry is something is a database, okay, um, where you can configure settings for multiple things in Windows. So there are different registry hives. HKLM is for local machine. For example, if you can see this in the diagram, HKLM, H key local machine is for local machine. Local machine means it will be every whatever changes you make in these settings will be applied to whole system. Whereas there is one more path that is for current user, H key local user. Um, so if you make changes to that particular registry path, so whatever changes you make will be applied to only particular user, current user basically. Um, so yes, okay. You can use a registry editor. So registry editor looks like this. If you go to Windows, search for, sorry, here you search for registry editor. So it looks like this. Um, so this is what I was talking about, current user local machine. Um, yes, so this is registry editor. Now this particular malware code is looking for this path, HKLM software Microsoft version, so Microsoft Windows current version, and checking for a value for program files dir. So let's see that in our registry editor, HKLM software Microsoft Windows, software Microsoft Windows and current version, and this is the registry key which is being checked by the malware. So this is the code which checks whether this key exists or not. If yes, registry query executed successfully. If it doesn't exist, fail to execute registry query. Simple function. We don't have to understand this code in detail. All we need to know that this function is designed to check the system registry for a specified directory path, program files dir. This path's presence or absence helps the malware determine whether it is running in a typical virtualized environment like a sandbox. Okay, so if this path does not exist, uh, malware assumes that this is a sandbox. Can YARA do it? Mere malware knows that MaxKD is a big fan of YARA rules. YARA is a tool to use to identify and classify malware based on patterns in its code. By writing custom rules, analysts can define specific characteristics to look for, such as particular strings, file headers, or behaviors, and YARA will scan files or processes to find matches, making it invaluable for detecting malicious code. Okay. Mere malware does not think such a simple tool can detect his malware, but just to be sure, he has to test it out himself. Okay. To do this, he wrote a small script that executes a YARA detection rule every time a new event is added into system monitor log. This particular YARA rule detects any command that tries to access the registry. Let's have a look at the rule. Okay, this is the rule created to detect um, mm, to detect any command that tries to access this registry. Okay, so this rule is created uh, to detect whether any program tries to access this particular registry path. Okay, and whenever any program tries to access uh, any registry path, a event is generated in SYSMON logs, and we are just verifying. I think we this YARA rule just queries the system logs, if I'm not wrong, maybe. Um, let's understand the contents. String in the string section, we have defined the variables that include the value to look out for CMD. Yes. In the condition section, we define when the rule will match the scanned file. In this case, if any of the specified strings are present. Condition section. Okay, so this is very simple rule. Uh, for his testing, Mere Malware has set up one function script that runs the YARA rule and logs a true positive in C tools YARA matches.txt. Open up a PowerShell window, navigate to C tools directory and use the following command to start up the EDR. Okay, copy this. Let's go to C tools. Open PowerShell. So we are already running as administrator user here, so we don't need to run like right click and run as admin, because we are already provided with the credentials of administrator user. We are already admin. You can check that by running who am I as well. So we are a administrator user. Cd dot slash and tools folder, I believe. Yes. And here we are having the jinglebells.ps1 file. Notepad.exe. Jingle bell. This is the file. YARA rule path is this. YARA executable is here. Log file path is this. And we don't need to go into detail. I can go into detail, but I don't have that much time, and it is not required for this particular challenge. Um, so basically this script monitors for SysMon events, and it also runs YARA .exe with the particular YARA configuration, this rule. So if any events occurs which matches this rule, we will be getting the output in this file. Okay, so let me run this. PowerShell.exe minus execution policy bypass dot slash jingle bell. Okay, it is running. Now we need to run our malware, which is available at this particular location. So let me run that as well in a new window. PowerShell. And also let me open the file side by side, which will be containing the output. I want to see everything side by side. Notepad .exe. Okay, currently it is empty, and everything is running. Now let me run the malware. Cd malware, cd tools, cd malware dot slash merry christmas dot exe, and run. Registry query executed successfully. So registry path exists, and we have already checked that, and we got the notification, and we got the event as well, which was detected by the YARA rule. So everything you see here is being logged in this file. I just need to reload this. I don't know how to refresh a file in Notepad. I think we cannot do that. Um, so let me reopen the file. Notepad, YARA matches. Yeah, okay. Yes, so we got the event captured in our log by the YARA rule. Okay, very good. Um, if our custom script did its job, you should have witnessed a pop-up. Yes, we have. Um, flag included. Okay, flag is also there. Yes, glitch was here. So this is the flag for question number 1. Let me answer that. THM glitch was here. Okay, glitch was here. TCH was here. Okay, let's proceed further. Um, Adding more evasion techniques. So this can be detected as we saw. If someone creates a simple YARA rule which checks for uh, system events for this particular registry path, uh, this type of malware can be detected. Next is uh, adding more evasion techniques. It seems that YARA can detect evasion that mere malware has added. We have seen that. No worries, because we can make our malware even stealthier by introducing obfuscation. Now here we are using encoded PowerShell command to query the registry. Instead of using a C program for registry querying, we are running a direct PowerShell command to query the registry path in this particular case. If you want to see this, just copy this and oh, let me, yes, open terminal, and there is a base 64 command in Unix. you need to copy the encoded command and paste in echo, then pass this to base 64 minus d. Minus d is for decode, and this is the command which is being run um, in the PowerShell. So like this, encoded command, and here this command is going. Okay, while obfuscation is helpful, but we need to know. So what is happening here is the malware.exe. If you run like strings command in Unix, if you are aware of that or not, I don't know. So there is a command in Unix, strings. So you can run this command on any file. For example, just for example, I create a file named as test with string hello hello garbage, and save this, and I run this command now. Temp slash test, pass this to strings, uh, and you will get all the strings which are there. So in a binary, um, it is not always the case. This will not be the case because I created a text file. The binary file contains non-printable characters as well. So you will, if the binary, I mean the .exe file contains a string, um, like which contains the path of the registry, so you will be able to see the path um, directly using strings command. So what I'm trying to say is there is a similar strings functionality in Windows that is mentioned here, floss.exe, and this is developed by Mandiant, uh, Google basically. You can run this on a exe file, and it will show you all the strings just like we saw here in Unix. I'm not sure if I can copy this file to my Unix. Uh, Let me try that. If I can show you the same thing using strings command. Tools, malware, copy, and home. Let me open my file manager. Okay, desktop, paste. No, I cannot paste. Uh, Drag and drop maybe. Drag and drop is also not working. Okay, I am being stubborn here, but there should be some way to do this. Do we have Python? Python. Yes. Okay. Okay, we can do that. I believe now because we have Python. Um, so let's create a -m simple oh sorry, http dot server using Python, and this particular module is already installed. I mean, you will get this by default when you install Python. And a web server is running on port number 8000. Um, our IP address is 10.10.203.240, and call 10.10.230.203, sorry, and 240. Port number is 8000. Let's see. Yes, we can. Okay, we can transfer files. Uh, what TryHackMe should have done is they should have allowed only port 3389, but that particular restriction is not in place. That is good for us. We can transfer everything from TryHackMe lab to our system. Proxy, I beg your pardon, sorry for this. I forgot to, yes, it is set. No proxy. Reload. Okay, this is regular malware, this is obfuscated malware. I want both. Save. So my malware is stored here, strings, and Merry Christmas.exe. Now if you look for all the strings in this binary, you will be able to find C program file somewhere, hopefully. Let me search program files is there. Okay, dir, and Windows path is also there. So yes, um, this is what I wanted to show. Like, string command is used to get all the strings which are present in the binary, and because the malware developer has not used obfuscation for changing the strings in the code, um, malware can be detected easily just by running the strings command. I hope it makes sense to you. If it is not making sense to you, read this again. It will make sense. Um, so for getting the flag, you need to run this command. I think we already entered the flag, so ignore this. You can search for the flag as well here. THM, it should be somewhere here. Hidden clue. Hidden clue. Okay, no, this is separate flag. So yes, you need to run the strings command or this loss.exe to get the next flag. Okay. Now, if we run the same strings command to obfuscated binary, which contains encoded um, PowerShell command, you will not be getting the program files here. Let me open this in new window. Strings, paste, search again. Um, program. No, so okay. There is no program. There is no string with the keyword program here in the obfuscated file. So this is how obfuscation works to make sure your malware is undetected, or to make it stealthy. Try to encode your strings, whatever strings you are using in your code. But I think base64 string will be there. Yes. So base64 string is still there. Uh, so if the strings command also has a functionality to decode the base64, you will be getting this um, the real command with the program files, path, and everything in the output. Um, I think floss.exe does that thing. Let me check with the floss.exe now on this file. Let me turn off the server. Floss.exe is at the tools floss folder. cd dot dot cd floss.exe dot slash malware Merry Christmas obfuscated.exe, and out file for all the malware strings. We are just storing the output in a file. C tools mal strings empty. Okay, still going on. Sorry. Decoding strings. Okay, so floss.exe does the decoding part as well. It is advanced than strings. Rendering results. Okay. Merry Christmas dot obfuscated.exe. Okay, this is the encoded command. Down. Floss static strings program. I don't think it is detected, but I don't know. Okay, you can go through that output slowly. Maybe you will find something. Hard coded variables. We saw this using strings command. Um, I don't know. Maybe it has some other functionality. But it it looked like it is doing the decoding part. In reality, maybe not. Let me once more search in output. Find program files. No. PowerShell. PowerShell. Okay, this was already detected by strings command. So no, even this flaws thing is not able to detect encoded command. Um, these YARA rules are becoming a pain to Mayor Malware's backside. If he wants his malware to be undetectable, he needs to research how YARA rules can be used to stop him. For example, his research tells him that YARA rules can also be used to check SYSMON logs for any artifacts that left by the malware. He will need to test this as well. Okay, SYSMON is a tool which is a part of this internal suite. We know that this Windows service provides detailed event data on process creation, network connections, and file changes. YARA rule will look for events with event ID process created. For this to work, there are many entries in the sysmon log. To make it easier to find the event which we are looking for, we will apply custom filter using the event record ID that we can see in the log YARA matches located in tools. YARA matches, this one which we uh, got in the challenge number 1, and event record event record ID, this thing 128076 128075. I don't think it is related, it is just incremental. Open PowerShell window and enter the following command to check the contents. Okay, note down the event record ID value, create a custom filter in the event viewer. By this, insert event record ID here, and we will be able to see all the events with that particular ID. Event record ID, apply the filter. Okay, you will get the event related to the malware. Click on the event, and on the details you should get the following output. Okay, so this is what is being shown here is how to filter out the particular event from event log. Okay, so we don't have to do that because there is no question asked regarding that. um, so yes, okay, click here, complete, and that's pretty much it for this particular challenge for task number 12. um, I hope you learned something new. Thank you for watching. Bye bye.